This notion of platform power management technology, or actually what's called converged platform power management technology at Intel. If you attended one of the IDFs, I think about a year and a half ago, I actually gave an early demonstration of this technology where we showed how managing power within the platform, not just at the processor level, but at the full platform level, could pay off handsomely and deliver dramatic reductions in platform power, both idle power and active power. And we actually showed an example of this on stage where we were able to quiesce the platform for longer periods of time by removing sources of periodic polling within the platform that forced us to wake up the processor, and bring the operating system to the point where it was able to make a decision whether anything had changed and it needed to take action, or the system state had not changed and it could just put the system back to sleep. So there was this periodic waking up of the platform just to see if anything new had happened. What we showed in that IDF demonstration was the ability to keep the platform quiet for much longer periods of time, rather than intervals typically on the order of 10 milliseconds. We could keep the power shut off for periods as long as 600 milliseconds and only wake up the platform when it was absolutely necessary to take action against most likely some sort of I/O interrupt. This required not only modifications to the platform, even changes to the interface specs on things like USB, but it also required us to modify the operating system so it wasn't based on that notion of periodic wake-ups. And we showed these dramatic power reductions. So this is a technology that is now in active movement from research into product developments. And you're going to see it appearing not just on the client side, as we demonstrated at IDF, but also on the server side. One piece that's not shown here is the networking piece. There is a demo out on the floor that you want to get around to see, where we actively manage the network interface. And that enhances the power reduction. So now that we're able to take on the order of 50% of the platform power out of normal operation, because we're able to manage essentially all of the platform resources, including the network interface. When I talked about the work in the network interface, which you'll see today, at EPA a few months ago, that was the one thing that got them excited, because they sort of have this view that all these PCs are having to stay up to service the network interface. And when we showed them how you could basically quiesce the network interface for much longer periods, that really brought them out of their seats. So this is one to watch for. Another one that I mentioned is our work in high-level programming tools for multi-core and many-core processors. This is one particularly important example called CT, that's T for throughput applications. This is a high-level language interface built inside C++, so we don't actually change C, we just sort of tuck this in using the normal C extension mechanisms, and then provide a highly specialized runtime for supporting it. But this basically allows you to deal with a data abstraction that we call nested vectors. And you can use nested vectors to define all sorts of interesting data structures, from dense to sparse. And not just matrices. You can build linked lists and trees and all sorts of things using this idea of nested vectors. So you can write an application that has inherent parallelism, but doesn't require the programmer to express any of the parallelism in any detail. It's simply operations on collections of data. And then the decision of how to map that code onto the available processors, which may be homogeneous or may be heterogeneous, is actually made at runtime. And so we can support Intel multi-core processors. We can support future Intel many-core processors such as Larrabee and combinations. They're We've been working with a small number of external groups to refine the language definition, and they've all come back overwhelmingly enthusiastic about the language, actively suggesting enhancements in particular domains of interest to them, whether it's financial services or one area we've been working with, a company called Newsoft in China, that actually demoed some of their work in CT at the Shanghai IDF in the area of driver assistance technology. So image processing for automotive applications, where let's say you're doing anti-collision work or safety work, is there a pedestrian walking across the street, and actively bringing that information to the driver's attention. So we've picked a group of partners here to give us a variety of perspectives on how the language performs within those different domains. And the next step, of course, would be to take the technology from its research state today to full product status. And we think, given the response that we've had to CT, this is a highly probable one for future productization. So be sure